In this video, I'd like to talk about the math question of the day for Saturday, May 27th, 2023. And with this problem, we have our function f of x, and we need to let c be the number that satisfies the mean value theorem for the function f on the interval from -6 to 0. And we need to figure out what is that number c. So the mean value theorem is typically taught in a Calculus 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you've attempted the problem, let's start working through this. And with the mean value theorem, let me paste in a definition so that we can better understand what it is. And with this theorem, we will suppose that we have some function f of x that satisfies these conditions, that on a given interval, it's continuous and differentiable. And if those conditions are met, then there is a number c such that c is between a and b, and the derivative at c is the difference in the function values at these endpoints divided by the difference between the endpoints. So this might seem a little bit abstract, but if we draw a quick sketch, it's fairly intuitive. Let's say we have some function on our standard xy plane, and we can say this function is f of x or g of x, whatever you would prefer. Let's just call it f of x, and let's say that we're dealing with endpoints of a and b. So let's find the function at those different points. This y value will just be f of a, and this y value will be f of b. And basically what this theorem is saying, if we focus on the right-hand side, is that if we find the average rate of change between these points, a and b, or in other words, if we draw a line between these points and we find the slope of that line, that's what this right-hand side is, that just finds the slope of this secant line, then on this interval, there is some point c here where if we drew in the tangent line to c at that point, then it would have this exact same slope. And it might be hard to pick it out exactly where it would be, maybe somewhere here. And I should mention it could be multiple points. It doesn't just have to be one point, but there is at least one point such that when we draw in the tangent line at that point, it will essentially be parallel to this secant line. Or in other words, it will have the exact same slope as that secant line. And again, we can call this point C. Now, the mean value theorem doesn't explicitly tell us what that value c is. It just tells us that there is some point on this interval where c exists and has this exact same slope. So that's the essence of our mean value theorem, that the derivative at c, or the slope of the tangent line at that point c, is equal to the slope of the secant line when we look at the different endpoints. So we can use this theorem to answer a question like this. We are told what our interval is, and we're told what our function is, so we have enough information that we can figure out this side of our equation. And from there, we can figure out what c is. So let's start with that interval. We're going from x values of -6 to 0, including those points. So with our formula, we can say that b is 0 and a is -6. And we also need to figure out the function at those points. So let's plug in for f of 0 here. That would just be 0 plus 0 plus 0, so that's 0. That's straightforward. And then f of -6, if we plug that in, we are cubing it. So that would be -216. Then we have plus 6 multiplied by -6 squared, which would be 36. And then we are adding 6 times by -6, which means we are subtracting 36. And 6 times 36, that is 216. So minus 216 plus 216, that's just 0, and then we have negative 36 at the end. So with this information, we can figure out the right-hand side of this equation. So let's start writing that down. We have f prime of c is just equal to f of b, which, since b is 0, that is just 0. And we're subtracting f of a, and a was negative 6. So f of a is negative 36. We're subtracting a negative, which is the same as adding. And then we divide by b minus a, or 0 minus negative 6, which is 0 plus 6. So we have 36 over 6, which is equal to 6. So this point C on this interval would have a derivative equal to 6, or the slope of the tangent line at C is equal to 6. So our next step is to take our function and find its derivative, and then set that derivative equal to 6 to figure out the C value on this interval. So let me make a little bit of room so that we can keep working, and let me paste in our function here. And like I said, we just need to figure out this function's derivative. So now we want to find f prime of x, and we'll use the power rule. We bring down the exponent, and we multiply, and then we subtract the exponent by 1. So we have 3x squared from this term, this cubic term. For this quadratic term, we bring the 2 down. 2 times 6 is 12. Then we multiply, and we subtract the exponent by 1. So now it's 12x to the first. And for this one, it has an exponent of 1, which we bring down. 1 times 6 is 6. And we subtract this exponent, we get x to the 0, but that's just equal to 1. And 6 times 1 is 6. So this right here is our derivative. And to figure out f prime of c, we know that this derivative has to equal 6. So let's say that f prime of c, this is equal to 6, and this is equal to our derivative function. But now we need to find that specific x value where this equation is true. So let's solve this quadratic. We'll subtract 6 on each side. We get 0 is 3x squared plus 12x. And we can divide everything by 3 so that we get x squared plus 4x. And we can factor out an x here so that we get x multiplied by x plus 4. And there are two solutions here. We can see that when x is 0, this is true, and when x is negative 4. Now, with our two solutions, notice that 0 is on the border. And it is technically within our interval, but notice we have this point within our mean value theorem that our C value must be between our border points, but it can't be one of these. We don't have equal signs on these inequalities here. So 0 is not inside this inequality here, which means that negative 4 is our only solution.